Hello Philippines and hello world. For this video, we will talk about continuity. As stated, a function of one variable is continuous if its graph is an unbroken curve without jumps or holes. To extend this idea to functions of two variables, the precise definition of continuity at a point for functions of two variables is similar to that for functions of one variable. We require the limit of the functions and the value functions to be the same at the point. So, we will discuss the continuity of more than one variable, that is for multivariate function. Definition. To define a function f of xy is said to be continuous at x sub 0, y sub 0 if f of x sub 0, y sub 0 is defined and if the limit of f of xy as xy approaches x sub 0, y sub 0 is equal to f of x sub 0, y sub 0. In addition, if f is continuous at every point in an open set R, then we say that f is continuous on R. And if f is continuous at every point in the xy plane, then we say that f is continuous everywhere. Now, let's discuss some theorems that illustrate some of the ways in which continuous functions can be combined to produce new continuous functions. First, we have, if g of x is continuous at x sub 0 and h of y is continuous at y sub 0, then f of xy is equal to g of x, h of y is continuous at x sub 0, y sub 0. Second, if h of xy is continuous at x sub 0, y sub 0, and g of u is continuous at u equals to h of x sub 0, y sub 0, then the composition f of xy is equal to g h of xy is continuous at x sub 0, y sub 0. Third, if f of xy is continuous at x sub 0, y sub 0, and if x of t and y of t are continuous at t sub 0 with x of t sub 0 is equal to x sub 0 and y of t sub 0 is equal to y sub 0, then the composition f of xt, y of t is continuous at t sub 0. The content of the mentioned theorems can be summarized with the following remarks. First, a composition of continuous functions is continuous. Second, a sum, difference, or product of continuous functions is continuous. And third, a quotient of continuous functions is continuous except where the denominator is 0. Let's take a look at this example. Let the piecewise function f of xy equals to sine x squared plus y squared all over x squared plus y squared if xy is not equal to 0, 0. 1 if xy is equal to 0, 0. Show that f is continuous at 0, 0. Solution. We have to prove that f of xy is continuous at 0, 0. f of xy is equal to sine x squared plus y squared all over x squared plus y squared for all xy not equal to 0, 0. And f of xy is equal to 1 for xy equals to 0, 0. So we find the limit of f of xy at point 0, 0, and if exists, then the function is continuous at 0, 0. Limit of f of xy as xy approaches to 0, 0. Then limit of sine x squared plus y squared all over x squared plus y squared as xy approaches to 0, 0. We let z equals to x squared plus y squared when xy approaches to 0, 0. Then z approaches to 0. So we have limit of sine z all over z as z approaches to 0 is equal to 1. Because f of 0, 0 is equal to the limit of f of xy as xy approaches to 0, 0, so f of xy is continuous at 0, 0. That's the end of our video. Thanks for watching.